Welcome back. Amplifying the band involves setting up microphones and direct boxes to capture the best sound of an instrument on its way to the console so that it can be processed and mixed. However, like everything in live sound reinforcement, there's a right way and a not so right way to do that. In this segment, we're going to examine some time-proven techniques for amplifying a basic four-piece band. Dave, first, is there a standard process you use when you amplify a band?
It depends. If I'm working with the same band every night, then yes, because I know what the drummer needs, I know what kind of keyboard rig I've got. Basically, I know what I need to do.
Okay, well, what are some of the first things you do?
Well, first, I like to get the mic stands up, then the mics, then run mic cables, then connect the direct boxes, then make sure everything is connected to the snake.
Let's talk first about microphones. We know that all microphones perform the same function, but they do it in different ways. Why is that important for a sound engineer?
Because the process by which, say, a ribbon microphone works makes it far more fragile than a dynamic.
So there's a question of durability.
Yes, and that's a huge concern as a live sound engineer. All it takes is for a drummer to smack your real expensive ribbon microphone and ruin it for you to learn that lesson.
So don't use ribbon mics. Okay, so what mics do we use for sound reinforcement?
Primarily dynamic and condenser mics.
Well, let's get technical for a moment. How does a dynamic mic work?
Inside a dynamic microphone, there is a moving coil within a magnetic casing.
Sound waves strike a thin plastic membrane or diaphragm, which vibrates in response. A small coil of wire is attached to the rear of the diaphragm and vibrates with it. The voice coil itself is surrounded by a magnetic field created by a small permanent magnet. It's the motion of the voice coil in this magnetic field which generates the electrical signal corresponding to the sound picked up by a dynamic mic.
That's almost exactly how a loudspeaker works, except in reverse. So what makes a dynamic mic good for sound reinforcement?
Dynamic or moving coil microphones are very, very durable. Plus, they're cost effective, and they can handle just about any live sound reinforcement situation.
So cost, durability, and design. Okay, what about condensers?
In a condenser mic, sound waves vibrate a very thin metal or metal-coated plastic diaphragm. The diaphragm is mounted just in front of a rigid metal or metal-coated ceramic backplate. This assembly has the ability to store a charge or voltage. When the element is charged, an electric field is created between the diaphragm and the backplate, proportional to the spacing between them. It's the vibration of this spacing, due to the motion of the diaphragm relative to the backplate, that produces the electrical signal corresponding to the sound picked up by a condenser microphone.
Condensers are capable of extremely high-quality output. Plus, they have really good high-frequency response. This makes them a really good choice for hi-hats and overheads.
But condensers require separate power, don't they?
Yes, they require 48-volt phantom power, supplied either from the mixer or separate power supplies for each microphone.
Dave, what other considerations are there when selecting mics for live sound reinforcement?
I would say directional response and proximity.
Explain those two terms.
Well, without getting too scientific, a microphone is designed to accept and reject sound waves from the front, the back, and the sides of the diaphragm. The pattern by which the mic does this is called the mic's directional response.
What's important about that?
Well, in live sound applications, you often have several high-volume sound sources next to each other. Using a microphone with a narrow directional pattern, such as a super or a hypercardioid pattern, allows you to better isolate the sound source.
As Dave said, a microphone's sensitivity to sound relative to where the sound is arriving is called the mic's directional pattern. Microphone manufacturers use a polar pattern to graphically represent the mic's sensitivity in a 360-degree area around the mic, with the mic being in the center and 0 degrees being the front of the mic. Generally, microphones fall into one of three basic directional patterns: omnidirectional, bidirectional, and unidirectional. Microphones that are omnidirectional and bidirectional provide the least use to the sound engineer. The omnidirectional mic is sensitive to sound coming from all angles. As a result, an omni cannot be aimed away from undesired sources, which can result in feedback and other problems. The bidirectional mic allows sound to enter from the front and the rear. Although this may be useful for certain stereo techniques in the recording studio, it's rarely useful in live sound applications. The most useful directional pattern is the unidirectional microphone pattern. This is because it's most sensitive to sound arriving from one particular direction and less sensitive at other directions. As a result, unidirectional microphones isolate the desired sound from unwanted off-axis sound, as well as ambient noise. The most common type of unidirectional pattern is the cardioid pattern, which resembles a heart-shaped pattern. There are two variations of this pattern which are also important: the supercardioid and the hypercardioid. While the cardioid is least sensitive at the rear, when placed properly, the super and hypercardioid mic can provide more focused pickup and less ambient noise than the cardioid pattern. So what's proximity?
Come on, let me show you at the mixer. With certain mics, such as mics with cardioid patterns, the closer you get to the sound source, the louder the low frequencies become in comparison to the higher frequencies. And it's more noticeable at distances shorter than 4 inches.
Show us that.
Test 1, test 2. Test 1, test 2. Test 1, test 2. Test 1, test 2. One big advantage in close-up miking, say like on a guitar cabinet, is that you can cut low end at the mixer because you're getting more low end from the mic.
So you get more fullness while reducing the amount of pickup of more distant sound sources.
Exactly.
So together, proximity effect and directional response can help minimize unwanted pickup from the surrounding environment.
But you have to be careful about how you place it at the sound source.
Let's go talk some more about direct boxes. A lot of musicians are confused about direct boxes. Why do you use them?
For a couple reasons. First, when you're using a DI, you can bypass the musician's speaker cabinet so that you don't get all the leakage from all the other instruments on the stage, like you would if you had mic'd the cabinet.
So it's a way to get a cleaner, isolated signal.
Yes. Also, a DI box provides a certain amount of ground protection due to its ground lift switch.
How does it work exactly?
If you're taking the signal from an instrument itself, you plug the instrument into the DI input, then connect the output, which is really a loop through, into the input of where the instrument normally plugs in.
So what if the bass player has effect boxes?
Then I'm going to take the line directly out of the back of his amp and into my DI. Out from my DI on a balanced XLR, down my snake.
Okay, so do you follow any order when miking the band?
Yes, I recommend starting at the drums because they require the most mics.
What do you use in the kick drum?
In the kick drum, I'm using a Biodynamic M88. You could use an AKG D112, an EVRE20, a Sennheiser 421, or a Shure Beta 52.
And these are all dynamic mics?
Yes.
Okay, so show us how you place the kick mic.
I'm going to place the kick mic inside, midway through the shell, pointed directly at the beater.
So the snare's next?
Yes, the snare and the hi-hat. First, on the hi-hat, I'm using an AKG C391, which is a condenser mic and requires 48-volt phantom power. I have it pointed at the middle of the top cymbal at a 45-degree angle. Then on the snare, I'm using a Shure SM57, or sometimes I might use a 56.
Now, do you ever mic the bottom of the snare?
Occasionally, but if I do, I might not use the same mic.
Now, I know if we've got mics that close in proximity, there could be some phase cancellation, but we'll talk more about that in the video later on. How about the toms?
For the toms, I'm using 3 Shure Beta 98s, which are tiny condenser microphones. They're mounted onto the rim of the tom and pointed at the impact point of the head.
What else would you use on the toms?
Sometimes I use a Sennheiser MD421 or an EV408.
So what if you're on a budget and you can't afford all these great mics?
One solution would be to go out and buy a bunch of Shure SM57s. They're cheap, they sound great, and are incredibly durable, and you can use them on any part of the kit.
Okay, Dave, talk to me about these 2 AKGs.
For the overheads, I have 2 AKG C391s. Same type of mic that I'm using on the hi-hat. They're placed above the cymbals and at a 45-degree angle.
Okay, so we got kick, we got snare, we got hi-hat, we got a total of 8 mics. Okay, let's say you got 3 or 4 mics. What would you mic then?
Definitely 1 for the kick, and then 1 for the snare and the hi-hat.
1 for the snare and the hi-hat. Show us how you'd position the mic for that.
Well, I'm going to place the mic between both to hear the resonance of the snare and the hi-hat.
What about the toms?
Well, for the toms, I'd place a 57 right dead center in between both of them.
And then 1 for the floor tom.
Yes, and one for the floor tom.
Okay, so one for kick, one for the hi-hat snare, one for the mounted toms, one for the floor tom. That makes 4. But you like to use 8. 5 condensers and 3 dynamics.
Correct.
Okay, talk to me a little about synth drums or rototoms.
Well, for V drums or synth drums, I use a DI box. But for rototoms, I'm going to use a SM57 and mic it from behind.
Okay, so we start with the kick, mic the snare, hi-hat, mounted toms, floor toms, and the overheads.
Yes, I'm going to work around the kit, miking everything, cabling everything, and plugging it into the snakehead, and then making sure that all the cables are neat and clean.
Dave, how important is mic placement?
Very important. Mic placement is key to getting an accurate representation of the instrument. And then from there, I can adjust the gain and EQ at front of house.
Great. Okay, so let's move on to the keyboards.
I'm using DI boxes for the keyboard rig.
So out of each keyboard, into a DI, down to the snake.
Correct.
Okay, now in a recording studio situation, you'd want to keep each keyboard separate. Would you do that in a live situation?
It depends. If the keyboard player is just using 1 or 2 boards, then it's no problem to assign them to their own channels on the mixer. However, most keyboard players have a rig with several different keyboards and synthesizers they use to play different parts at the same time during a song. If that's the case, then it makes more sense just to take a left and right output from their onstage mixer.
So now the bass cabinet. What's the reason for using a direct box instead of miking the cabinet?
Generally, it's easier to control the tone of the bass at the front of house mixer than it is from up on stage. Basically, it's cleaner and it's easier. However, in some situations, I will mic the cabinet and take a direct out from the back of the amp. Then I'll put them into 2 separate channels and I'll mix them together.
Okay, so what do you do here at the guitar cabinet?
Typically, I mic the guitar cabinet.
And what kind of mic do you use?
I'm using a Shure SM57.
And that's a dynamic mic.
Yes, and I have it aimed slightly off-center of the speaker cone.
So you'd mic the guitar amp, but you take a line out for the bass amp. So why not use a direct box for the guitar cabinet?
Bass amps have speakers that don't have a lot of top end.
Oh, as a result, the high-end frequencies are lost from the bass instrument. So you use a direct box to get that top end back from the instrument.
Exactly, but guitarists rely heavily on the actual amplifier. The power circuit, the tube, the speaker all shape the sound of the guitar, which means I'm gonna have to mic it.
What if the guitar player uses an effects board? Do you still mic the guitar cabinet, or do you use a direct box from a line off the head?
No, I'd still mic one of the speakers.
Okay, how about the mic for the lead vocal?
For the vocals, I'm using a Shure Beta 58. It can take the sound pressure level, it's incredibly durable, and it sounds great. I'd also recommend a Shure SM85 or Beta 87.
What if the lead vocalist is using a wireless?
I'm assuming that we're talking about a diversity receiver, which has a mic output on the back, which I'll run into the snake, just like I would with any other mic.
So you keep the receiver on the stage?
Yes, it's less prone to drop out if I keep the receiver as close as possible to the transmitter.
When miking an acoustic grand piano, there are 3 basic methods. First is using a single mic. Although using 2 mics is standard for any reasonably high-quality pickup, in a pinch, a single mic can be used. With the cover open, place a condenser mic between 4 and 8 inches above the high upper strings of the piano plate. Listen carefully as the piano is played and adjust the mic to achieve an even balance between the upper and lower register. For stereo miking, place one mic 4 to 8 inches above the higher upper strings and the second mic in a position to pick up an averaging of the lower strings. Listen carefully to the piano being played and adjust the mics to achieve an even balance between the upper and lower register. Besides providing a good stereo image of the piano, this dual mic technique allows for separate EQing when necessary to deal with the varying character of high and low strings encountered in different pianos. If circumstances call for the piano lid to be closed during a performance, this third technique, building a tape bridge, is a perfect solution. First, above the upper strings, lay 2 strips of gaff tape across the outside and middle down bearings of the piano plate. The plate is the cast iron frame to which the strings are attached. Lay 2 more strips of tape across the central and outer down bearing above the lower strings. Then, place the mics in the middle of both tape bridges and tape them down. Next, attach the mic cables and run them around the inside of the piano and out the hinge side of the lid. Notice that Dave has looped and taped the mic cable to the center down bearing to prevent it from coming in contact with the strings. For these examples, we've used AKG C414 condenser mics because of their good transient response. Once the cables are run, simply close the lid. Okay, Dave, you've showed us everything on stage. Could you go back through maybe and tell us specifically, though, what kind of mics you're using, what kind of directional pattern they have, and whether proximity is a factor? Maybe starting with the drums.
Sure. The kick is a dynamic Beyer M88 with a cardioid pattern, and proximity is a factor. The snare mic is a Shure SM57 with a cardioid pattern, and proximity is a factor. The hi-hat mic is a condenser AKG 391 with a hypercardioid pattern, and proximity is not a factor. The tom mics are beta 98s with a supercardioid pattern, and proximity is a factor. The floor tom is a Sennheiser MD421 with a cardioid pattern, and proximity is a factor. The overheads are condenser AKG 391s with hypercardioid patterns. Proximity is not a factor. The guitar mic is a dynamic Shure SM57 with a cardioid pattern, and proximity is a factor. The keyboards are using 4 DIs, 2 for each board in stereo. The bass is also using a direct box.
What if the band is using horns?
I'd use a Sennheiser 421 or a Shure SM57.
How about congas or timbales or a percussion rack?
For congas, I'd use an EV408 or an SM57. For timbales, I'd mic them from underneath using an SM57. For a percussion table, I'd set up an AKG 391 condenser mic and have the musician play to that mic.
How about a turntable?
You need an RIAA preamp, which you can buy at Radio Shack, because you need to correct the frequency response of a turntable. Actually, there's all sorts of EQ that's done inside the preamp. Plus, a turntable's output is at a really low level, so you need the preamp to jump it up to line level.
All right, this would be an excellent place for us to pause for a moment and take a look at all we've covered in this segment. The two types of mics typically used in live sound reinforcement are dynamic mics and condenser mics. Condenser mics require a power supply, which many of the newer mixers provide as phantom power at the top of the channel. The directional pattern and the proximity effect of the mic are important considerations. Remember, the narrower the directional pattern, the more the mic can isolate the sound source. Using a mic with proximity effect allows you to mic the source closer, thus providing more isolation as well as more bottom end. Begin wiring up the stage by setting up mic stands and mics, connecting direct boxes and running cables to the snakehead. Mic the drums starting with the kick, aiming it at the impact pad behind the beater. Next, mic the hi-hat, preferably with a condenser mic if you have one. Point it down at a 45-degree angle towards the middle of the top cymbal. Then the snare, angling the mic towards the impact area on the top of the head. Remember to keep the mic towards the top of the snare so that there's less chance of the drummer hitting it. For the mounted toms, either a condenser or dynamic mic may be used. Using a rim clamp or a mic with a rotary head makes it much easier to keep the mic from being struck by the drummer. Mic the floor tom as you would the snare, pointing it down towards the impact point of the head. Because of their ability to reproduce strong high ends, such as that produced by the crash and ride cymbals, condenser mics work well for the overheads. Place them above the cymbals, pointed down toward the set at a 45-degree angle. Depending upon your budget, there's a tremendous selection of dynamic and condenser mics available for live sound application. However, if you can't afford higher-priced mics, an inexpensive solution is to purchase several Shure SM57s and 56s. They're cheap, durable, and you can use them practically anywhere. Here are several good microphone selections for the drum set. For the kick, a Beyer M88, an AKG D112E, an Electrovoice RE20, a Sennheiser 421, and a Shure Beta 52. Another excellent choice for the kick is the AKG D112. For the hi-hat, an AKG 391 condenser. For the snare, a Shure SM57 or SM56. For the mounted toms, Shure Beta 98s, which are condenser mics, or dynamic mics such as the Sennheiser MD421 or the Electrovoice 408. For the floor tom, a Sennheiser MD421. For the overheads, 2 AKG 391 condensers. If the keyboard player is using a mixer, take a left and right submix output into 2 direct boxes and connect them to the snake using balanced XLR cables. If there's no mixer, take a left and right output directly from each keyboard into separate direct boxes and connect them to the snake. For the bass, using a direct box is a much more effective solution for getting a cleaner, more isolated signal from the bass. Experiment with miking the bass cabinet as well as taking a direct line and mixing the two signals at the console. For the guitar cabinet, use a dynamic cardioid mic such as a Shure SM57. Position it slightly off-center of the cone on one of the speakers. For the lead vocal, a dynamic cardioid or supercardioid mic such as a Shure Beta 58 is a good choice. Another excellent choice for a lead vocal mic is the Crown CM310A. This differoid mic is superb for high-volume sound situations. For horns, use a dynamic mic about 6 inches away, pointed directly towards the bell of the horn. Congas are mic'd from the top using a dynamic mic pointed towards the center of the head. Timbales are mic'd from underneath using a dynamic mic, such as a Shure SM57. For rototoms, mic them from behind using a dynamic mic, such as a Shure SM57. For a percussion table, set up a condenser mic, such as the AKG 391, and have the musician play to the mic. Amplifying the Band sets the stage for the next segment, which is the sound check. The sound check is important for several reasons. It gives the engineer an opportunity to hear the band in the room, to make any changes that need to be made, as well as to uncover and deal with any system problems. Although most engineers would agree there's never enough time to do a proper sound check, the pros know how to get organized quickly and effectively so that they can take advantage of the time they do have to make sure the system sounds good from the very first song. We'll be right back with more of Live Sound Reinforcement.